Welcome back. Today we're going to move on from graphing. We're still going to be solving systems of equations, but I'm going to show you how to solve it algebraically today. Now, I love these algebraic methods. I personally find them a whole lot better than graphing. So I hope you end up feeling the same because these are really fun methods. Now, the method we're going to cover today is called solving systems by substitution. And again, this is something I know you saw back in the 8th grade, but it's a really good idea to review to make sure that you recall how it's done. I do have a very particular way that I like to do it though. So I'd like to share with you the method that I do. So what you want to do is first, you need to make sure one of your equations is solved for one of the variables. Everything on this page, that's already done for us, okay? So I'm not too worried about that piece. We're going to wait for the second page for that. When you have one that's isolated, so here notice this y is already by itself, okay? That's the goal. That's what I'm really looking for. I need one of the variables by itself. And what am I going to do? I'm going to put a little box around it. I'm going to box the other side. I'm going to box what it's equal to. And then what am I going to do? Well, as substitution implies, I'm going to put it in to the other expression, to the other equation. So I'm going to rewrite my second equation using that 2x plus 1. And I'm putting it in the place of y because it equals y. They're the same thing. So that's why this gets its name, substitution. I'm substituting it in. And now from here, it's just pure algebra skills. So I'm going to take 3x plus 2x. That's going to give me 5x. I'm going to subtract the 1 from both sides and divide by 5. So I get an x of 2. Now, if you recall though from graphing, these are points that we're looking for. So just getting an x of 2 actually isn't quite the end of this story. We're going to need a little bit more. I need to take that 2. Now I'm going to put it up back in the box. Because look what happens when I put it in the box. Now, oh, I'm sorry. That should be a 2. I immediately get my other variable. And so then I can write my solution 2, 5. So that's why I like using the boxes, okay? Because you know what you're substituting, you know where you have to put it back into, and everything just seems extremely clear when you do it that way. So let's practice it again. Again, here's my equation that has one of my variables already solved for. So I'm going to box the other side of it. Okay? And that I'm going to put in the place of y. So I'm going to rewrite that entire second equation. But instead of using y, I'm using x minus 4. So to solve this, now I'm going to distribute that 3. So I get 3x minus 12. I'm going to combine my like terms. And add the 12 over. And now divide by 5. Now, something you may be noticing here. Notice you're not getting a whole number. And that is actually okay. So, 19 divided by 5 is 3.8. Okay? And I want you to know it is okay to get decimals. I'm not going to do it too often, and they're not going to be nasty decimals by any means. However, I do want you to be comfortable with decimals, okay? So Don't freak out if you happen to find one. Now, final step, put it back in. So y equals 3.8 minus 4. So that's going to be negative zero point 0.2. And again, always feel free to use your calculator for that. I know decimals get a little bit nasty and tricky, but what you're going to get is 3.8 and negative zero point 0.2. Something that would have been very difficult to see had you tried to solve this by graphing. Okay, it wouldn't have been nearly as nice to solve. So that's our substitution method. Now I do want to show you that sometimes you are going to have to solve one of the equations for one of the variables. It won't always be laid out so nicely. So take a look at our first one. Again, the variable isn't by itself, okay? So, but what I want you to see is ones that have a coefficient of 1. So where the variable doesn't have any numbers with it. So for example, this y here. The y would be relatively easy to isolate. All I have to do is subtract 2x from both sides and get y equals negative 2x plus 1. Then I don't need that equation anymore. So variables that don't have a coefficient, they're relatively easy to get by themselves. And now I can still use my substitution method. So now I can box the other side, okay, because now I have that y isolated, and I can put it in there. So 2x minus 3, negative 2x plus 1, equals negative 27. Again, just substituting in what y equals. And now to solve. So distribute the negative 3. So 2x plus 6x minus 3 equals negative 27. I can combine my like terms. 8x minus 3 equals negative 27. I can add 3 to both sides. Now here, be really careful. So negative 27 plus 3 is going to be negative 24. And then when I divide by 8, negative 24 divided by 8 is going to leave me with a negative 3. So again, lots of algebra skills required to solve each of these systems. But now that I have what x equals, now I'm going to put it back in the box to find y. So y equals positive 6 plus 1, or that gives you a value of 7. So my solution here is going to be negative 3, 7. All right, next one. So for this one, notice the x is almost by itself. All right, so if I subtract the 2y over, I'll have negative x equals negative 2y plus 13. All right, so again, this time noticing that my x is the one without a number coefficient with it. But the x isn't quite by itself, is it? I need to divide everything by negative 1 to get rid of that negative. And essentially, remember, if you divide something by negative 1, all it does is flip all the signs. So I'm going to have x equals 2y and a minus 13. And then that'll be getting that x by itself. And now, again, I don't need this anymore. Once I have that variable by itself, now I can start doing the substitution. So I'm going to put a box around what I'm substituting, and it's going in for the x. So 2x, which is the same thing as 2y minus 13, plus 5y equals 10. So I'm going to distribute that too. So 4y minus 26 plus 5y equals 10. Now I see some like terms to combine. So 4y plus 5y is 9y. Now I can add my 26 to both sides. And I can divide by 9. So I'm going to get a y of 4. And then what do? I take that 4 and I plug it into my box. So y equals 2 times 4 minus 13. So 8 minus 13 is going to give me a negative 5. So my x is a negative 5 and my y is 4. Okay, remember, each time you do this, you need to get the xy pair, all right? And you have to write it as a point. So, one thing I want to remind you of, those same cases as last time are back. So, graphing, you could get no solution and infinitely many solutions, but you can in this case too. And it happens very similarly to what we saw back in chapter 1. It happens if your variable completely cancels out of the equation. And then depending on what you have left, if you have left as a true statement, it's infinitely many solutions. If it's a false statement, you have no solution. So let me show you what that looks like. Here I already see one of my variables solved for. So I'm going to box the other side, and I'm going to substitute that in for y. So I'm going to rewrite that equation. 8x minus 2 times 4x equals 3. So 8x minus 8x equals 3. Well, 8x minus 8x, my variable completely dropped out. All I have left is 0 equals 3, a nonsense statement, a false statement. So what that's telling me is that this has no solution. Okay, if I were to graph these two lines, these would be parallel lines. They would not intersect at all. All right, so just a little reminder to not forget those special cases that can occur. So again, please write your summary for me right here. And then once you're done with your summary, come back to class prepared to do your practice work.